Hello everyone, my name is Anissa and today I'll be discussing the relation of John Dalton and Dmitri Mendeleev on the periodic table. John Dalton is remembered today for introducing the atomic theory into chemistry. The atomic theory first occurred to him during his investigation of olefin gas and carbureted hydrogen gas. From the experiments, he focused on both carbon and hydrogen, and he found that if he calculated the carbon in each the same, then carbureted hydrogen gas contains exactly twice as much hydrogen as the olefin gas does. This determined him to state the ratios of these constituents in numbers and to consider the olefin gas a compound of one atom of carbon and one atom of hydrogen, and carbureted hydrogen of one atom of carbon and two atoms of hydrogen. So Dalton adopts the Newtonian idea and pictured on paper the atoms of nitrogen, oxygen, and water vapor and tried to combine them in a simple numerical proportions to produce a mixture of uniform density, but he wasn't successful. He then distributed the various atoms uniformly in physical admixture as seen in the figure, in order that the mixture consequently formed should not separate into layers under the influence of gravity. He proposed that the various atoms were each surrounded by an atmosphere of heat, which causes like atoms to repel one another, but did not cause unlike atoms to repel one another. In this way only could he conceive the possibility of a uniform mixture. The atmospheres of heat round like atoms had to be all equal and different in size from the atmospheres round the atoms of another substance. So Dalton thereupon determined to find the relative sizes of the atoms of the gases of the atmosphere, and for this purpose had first to determine their weights. The first known reference to atomic weights occurs with a list of symbols to represent atoms of the elements and compound atoms as seen in the figure. In his representation, the elements were shown as small spheres, each with a separate identity. Compounds of elements were shown by combining the appropriate elemental representation in the correct proportion to produce complex symbols. The property of atoms of interest to Dalton were their relative masses, and Dalton produced a table of atomic masses that was seriously deficient because he did not appreciate that atoms did not have to be in a one-to-one ratio. Using more modern ideas, Dalton assumed incorrectly that all atoms had a valence of 1. The atomic mass of hydrogen is arbitrarily assigned to be 1. The atomic mass of oxygen is 8 on Dalton's scale. Dalton, of course, was wrong because a water molecule contains 2 atoms of hydrogen for every oxygen atom, so that the individual oxygen atom is 8 times as heavy as 2 hydrogen atoms or 16 times as heavy as a single hydrogen atom. There was no way that Dalton could have known from the data available that the formula for water is H2O. So how did Dalton help Mendeleev? Dalton's atomism held the initial idea of Mendeleev's work, in which the link between the chemical character of the elements and their mass or atomic weight appears as a general property of elements. He considered Dalton as a real founder of our atomic notions. The periodic law in Mendeleev's formulation expressed the dependence of the measurable physical chemical properties of the elements on their atomic weight. And it is not only the atomic weight, which is derived from Dalton's atomic theory, but also the maximum or extreme valence with respect to oxygen, which plays the role of independent variable in the functional expression of the periodic law. He extended to the realm of chemical elements the dialectic of chemical relations, which Dalton discovered in the realm of chemical compounds. He regarded the central idea of Dalton's atomism in the proposition that chemical substance unites in multiple proportions, that is, discontinuous and integral ratios without forming any intermediate products with fractional value of the constituent parts. So in other words, the chemical combination takes place by leaps. He found that the same skipping character of chemical change as the basis of the periodic law. He discovered Dalton's law of multiple proportions expressed the fact that in any series of the compounds of 2 elements, let's say nitrogen and oxygen, the valence of one element changes, in this case, nitrogen from 1 to 5. Within each row of Mendeleev's arrangement, the maximum valence with respect to oxygen rises. That is, in short periods, it rises from 1 in the alkali metals to 7 in the halogens. The discoveries of Dalton's and Mendeleev thus appears as links in a single change of development. The first discovery engendered and prepared the way for the second, and the second was the logical prolongation and completion of the first. Together they form the basis of the modern theory of matter, and constitute the landmarks of the 19th century chemistry. The period of atomistic chemistry began by Dalton's discoveries and is completed by Mendeleev's scheme.